All right, here we go. Next intervention is Go. So what we're going to be looking at today is a topic that when I showed you the topic lists and things like that, a few people said they'd like a little bit of refresher on box plots and quartiles. So this is what this video is going to be. It's going to be a refresher mostly. What I will do towards the end is show a few more challenging scenarios, but also I will show you how to use your calculator effectively to calculate box plots. To calculate quartiles. Your calculator won't draw a box plot for you, to the best of my knowledge. So what we're going to jump in first is what they are, how we get them, and then step things up the further we go along. So without further ado, let's go. Let's have a look. So some keywords first and some key ideas. A median, hopefully we are very aware what a median is. It's a middle value of a data set. Is what we kind of in a posh way called a central tendency. Okay, and the reason why we like the median as an average is that it's a good comparison for different data sets because it's in the middle. It completely disregards outliers. Okay, so it won't be affected by a very high outlier like a mean would. And it also it kind of just gives you a sense of what that that data set is like. Okay, so the median is a very good tool for comparing data. The way that we find a median, we look for the value in the middle. You may remember back to some days of year 7 and year 8 where you might cross things off from both sides to get to the value in the middle. Or if you've got a lot of data or data that's given to you in a table, you can use a little rule where you take the number of items in your data set. That's what the N stands for here. That's your total frequency. Add 1 to it, and then divide by 2. And this will tell you where your median is. Not what your median is, but it'll tell you where you can find it, or which bit of data you're looking for. And we use the n+1 divided by 2 for most scenarios. If we're using a cumulative frequency, because the graph we've drawn will be kind of a little bit inaccurate to the true data, because of our curves or the way that we've drawn it, we can afford to do n over 2 instead and not do the +1 just to make things that little bit easier for us. Though Edexcel have said that they will accept either as a way for calculating the location of the median. Okay, a quartile, it's got that word quarter in it, nearly, is the median of each half. Okay, so that's really poorly written from my perspective. It's the median of each half. Okay, so when you've found out where your median is, you should split your data into 2 halves, and then your quartiles will be found in each of your halves. Okay, between your upper quartile and your lower quartile will be 50% of your data. Okay, so that gives you some key ideas of what your median is, why we use it, it's a good comparison value, and what the quartiles are and why we look at them, because they house the middle 50% of your data. And it's the quartiles, again, they get to ignore those outlier values for the most part, okay? Because, again, it's like a median of your medians, okay? So that's what they are. That's how we can get them in terms of using our formula. We will take a look at both ways throughout the course of this video. We're going to jump into the easier way first things first. Okay, so the following is a set of data showing the amount of people in a class. We've got loads of different numbers for different classes, and we want to find the median and quartile values for this data. Okay, now you might remember from your days of lower school and things like that actually first thing we need to do is get this data in order. So what have we got first? We've got 8 first. Let's cross it off so we know we've done that. Then we've got 14, then 15. Let's cross off those. 15, 16, 21, 22, 23, 24, 25. Right, we've got two 26s, two 27s. So let's cross those off first of all. Two 26s, two 27s, a 29, two 30s, and a 32. And you can see that's just helped me get all of my numbers and make sure I've got them in order. And you can see that I've actually still got all of my numbers. That's a good thing. Right, so I can now effectively cross off one from each side until I get to the middle, which on a foundation or a crossover tier would be perfectly acceptable. So we'd have one from there, one from there, one from here, one from there, one from here, one from there, 4 from both sides, 5 from both sides, 6 from both sides. Our median is in the middle. And we want to know for this what's in the middle of 26 and 27. It'd be 26.5 is our median value. Okay. But just to show you that it works, just to show you that you can do this, I'm going to use that n+1 divided by 2 thing as well. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. So n is equal to 12. n+1 divided by 2, or 12 plus 1 divided by 2, is 13 over 2, which is 6.5. So what I would be looking for is my 6.5th bit of data. Well, 1, 2, 3, 4, 5, 6. There's 7. 6.5th will be in the middle of my 6th and 7th. So that's in the middle of 26 and 27, which is 26.5. Okay? And if you get two values which are far apart from one another, you might be able to just do 26 plus 27 and then divide it by 2. Then that's how you find a midpoint of anything. You add the two numbers together and divide by 2. Okay, I'll just stick this in a little box, just as an aside. That's the n+1 divided by 2 method. Okay, you would need to use that method if you are in a table or you've got lots and lots of data. Okay. So there is our median. Happy days. We now want to find our quartiles. Now we said that our quartiles were the median of each half. So what I need to do first of all is to actually split my data in half. So I'm going to just stick a little line down there to say there's my half. Okay. Now what I need to do is I've got 1, 2, 3, 4, 5, 6 pieces of data here. So I could again cross off one from each side until I get to the middle. Or I can say that 6 plus 1 divided by 2 to get me the location of the median would be 7 over 2, which would be 3.5. So looking for the 3.5th bit of data, we've got 1, 2, 3, and a half. So our lower quartile, or Q1, as they may sometimes call it in other textbooks, is going to be between 15 and 23. Now that's a bit harder to know what's exactly in the middle, unlike the 26 and 27 we did before. So I'm going to add them together and divide it by 2. 15 plus 23 divided by 2. Well, that's going to give me 38 over 2, which is going to give me 19. So that is my lower quartile. Okay, and I'll pick a different color again for my upper quartile. I'm going to go, I'll go green this time. So because I've got the exact same number of data bits on each side, I know that my upper quartile will also be 3.5 bits through the higher set of data. So this bit here is going to give me my upper quartile, or Q3 in some other textbooks. This one is a bit easier to tell. In the middle of 29 and 30, I have exactly 29.5. And I'm going to just summarize all of this information for us. So the median we've said is 26.5. Our lower quartile is 19, and our upper quartile is 29.5. Bing. Done. Okay, so I'm going to reveal one underneath that you can use to practice, and as usual with these videos, I'll say you can now pause the video, you can try out the question, and then use the solution that I do afterwards to check your answer. So here we go, here's the question. Same thing again, find the median and the quartiles. Your time to pause. Okay, so hopefully you've had time to pause the video and have a go at it, and now you can check your answers. Now, for this one, again, we're going to have to put everything in order first of all, so let's do that first. We have an 8, a 9, I'm going to cross those off. What's my next lowest? 16? Yep, 16, then 18. 16, then 18. What we got then? 24? Yes, 24, then 25, then 26 by the looks of it. 25, 26, 27, yep, 31, 32, 33, and 34. Gosh, the end of that data was very nice. That lower quartile looks a bit interesting though. Right. Median. We could do the method where we cross off one from each side, or we could do our n+1 divided by 2. I think I've given you the exact same number of data parts as well, which I really shouldn't have, just to vary things up. But yeah, n is 12 again. So from the same as before, 12 plus 1 divided by 2 is 6.5. That's where my median is going to be. So 1, 2, 3, 4, 5, 6, and a half would be halfway between 25 and 26. So our median is 25.5. Our lower quartile is going to be the median of the lower half, which we can see should be in here somewhere. We could do exactly the same thing, where we could say we have 6 pieces of data in the lower quartile, in the lower half. 6 plus 1 divided by 2 is 3.5, so that's why I'm looking for the 3.5 piece of data. Our lower quartile is halfway between 16 and 18, which is 17, and our upper quartile will be the exact same number, 3.5, but through the higher half of data. So 1, 2, 3.5 will take me to there. That is my upper quartile, which is going to be 31.5. There we go. Happy days. Yeah. So in terms of just a list of numbers, that is how we find medians and quartiles. And remember, your medians could be used to compare. So if we were comparing these two sets of classes, you know, they could be 2 different schools or something. We could say that in general, the median is very similar, but the median in the top school is 1 higher. So that means that on average, their classes are 1 person bigger. We can say that from the lower quartiles, the top one has a spread of 10.5 from the lower quartile to the upper quartile. And the lower school has got a spread of 14.5. So the spread of that second school is bigger, meaning that they are less consistent. The class sizes vary a lot more. Okay. Actually, that is worth noting here and we're going to have to write this in because we didn't have it here beforehand. So, quartile. Oh, that's not how you spell quartile. Good grief. So the difference of your quartiles is called the interquartile range. Okay, and what this does is it shows the spread of data. Okay, and importantly, this shows the consistency. Okay, a low IQR equals very consistent, okay, which is something that we would want. Generally, we want things to be very consistent. If we have a high IQR, oh gosh, we are not consistent, and that's something we generally want to avoid. We want to avoid being inconsistent. Okay? So, as we saw for this, the difference between the lower quartile and the upper quartile for the top school is not as big as the difference for the lower quartile and upper quartile of the bottom school. So we can say that the class sizes in the top school are more consistent, even though they are slightly bigger. Okay, the class sizes for the bottom school are more inconsistent, and they are slightly smaller, even though that's only one person on average. Okay, so that's the first part. Now, just for things to be awkward, things could be given to us in the form of a table, kind of like this. Okay, now I would rather not need to list out 99 pieces of data. There are definitely better uses of my examination time than to list out 99 pieces of data. So this is a case where using the n+1 divided by 2 is an absolute must. Okay, so remember that the n in the n+1 divided by 2, n is your total frequency, okay? How many pieces of data you have. In this case, we've got 99. So doing 99 plus 1 divided by 2, or 100 over 2, will give us 50. Now, our median will be the 50th piece of data. How do we find that 50th piece of data? Well, I've got 7 zeros, so this would only take me up to 7. I've got 10 ones. Now, add that onto the 7 zeros that I just looked through for the first bit, and I would have gone through 17 pieces of data. And this is called our cumulative frequency. Okay, it's like a running total. If I look at my 2s, I've got 14 2s, which would, on top of the 17 other pieces of data that I've looked at so far, would take me to 31. And I'm looking for my 50th number, because this is the location of the median. Okay, now, I've got 20 3s, which would take me to 51 pieces of data. Aha! We're after our 50th, which means that if I get to the end of my 3s, I've gone too far. Okay? I will have my 50th piece of data. It won't be my last 3, but it will be the one before that. So my 50th piece of data is a 3, which is our median. Okay? Now, this is saying, because I've got 50 pieces, well, I've got my 50th piece of data is our median, I know that I'm going to have 49 pieces of data this side, and 49 pieces of data this side to make up the 99 pieces of data overall. Okay, because I've got 49 plus my median, which give me 50, and then another 49 would give me 99 pieces of data. So if I wanted to find my lower quartile, I could then do n plus 1 divided by 2, with n being 49. Okay, which is going to give me, 25. So that will be the 25th piece of data. Now, it's not going to be a 0. It's not going to be a 1. Because there will take me 17 pieces of data to get to the end of my 1s. The 25th piece of data will be a 2. Because I'll have 31 pieces of data to get me to the end of my 2s. Okay? And I could do the same again for my upper quartile. 49 plus 1 divided by 2 is 25. So I'm again looking for my 25th piece of data on my upper quartile. Now I've got one piece of data that was left over from my 3s. Plus this would give me my 23 pieces of data. Plus this would give me my 42 pieces of data. Now I know that that is too much. I know that this was too few. So my 25th piece of data on my upper quartile must be my 5. Or it must be a 5 at least. Okay? Now, I know that a few people aren't so keen on doing it this way. I know that I've taught people in the past that don't particularly get on well with that way of thinking. So another way of thinking that you could have is, because these are quartiles, for that lower quartile, you can do n plus 1 over 4. Because it is a quartile. Okay, the n plus 1 would be for your 99 pieces of data. 99 plus 1 is 100. 100 divided by 4 is 25. For your upper quartile, and I think this is the one that it's helped people out with most, remember that your upper quartile will be 3/4 of the way through your data set. So this is going to be 3 n plus 1 over 4. Okay, n plus 1 would be 100, we know that. 100 divided by 4 is 25. 3 lots of that will give me 75. So I could be looking for my 75th piece of data, which means that I can just keep on counting. Okay, 51 plus 22 would give me to 73, and then plus the 19 would take me to 93, sorry. No, 92. What am I talking about? And I can see then that my 75th piece of data is that 5 that we selected for our upper quartile. Now this is kind of all doing things by hand. I'll show at the end of the video, I will show how you can use some calculators to do this, and I use that word "some" calculators quite explicitly, because not all calculators can do these things on them. Okay, but what about the box plots? Say that we've got a grips of our cumulative frequencies. Our box plots is what we want to do next, because we've got a grasp of our quartiles and our medians. Okay, and remember, a box plot should kind of look like this thing here, this thing in the middle. Okay, and each of these parts of a box plot mean different things. The line in the middle of the box is our median. Okay, and either side on the ends of the box are our lower quartile and our upper quartile. At the very ends, we don't have like 0 and 100 in terms of percentages, but we have our minimum value and our maximum value. Okay, so that within that box plot, we've got the very lowest, we got the very highest, we got the average, and we've got that central spread, that middle 50%. Okay, and that middle 50% is between your lower quartile and your upper quartile. And if you remember, we had a name for that. It's called the Interquartile Range. Okay, that covers 50% of your data. Now, if 50% covers the data in the box, then there must be 25% on each part of the box. Okay, no matter where that data is skewed to, that both sides of that middle box hold 25% of your data. And same goes with the kind of arms on the end, or the whiskers, some people call them. We have 25% on all of that for the end parts, so that the full then 100% of the data covers the full box plot. Okay. So the box plot themselves can be quite nice for holding quite a lot of information. In median, our quartiles, our lower quartile and our upper quartile giving us the interquartile range and the middle 50%, and then as well our minimum and maximum values. And the reason why box plots are so nice and looking at them in statistics is because they can offer comparisons very, very quickly. And even if you're not sure about what the box plot should look like, if you're looking at them, you can intuitively see what is going on with the data. So, for example, let's say we've got this. Say that we had two classes, Class A and Class B, that both sat a test. It was out of 20, and this is two box plots to show the differences between their scores. Okay. Now, normally we would look at the median and the interquartile range to do our comparisons. Okay. Because we want to look at that middle 50% and a central tendency, an average value. Okay? So the median is that line in the middle of our boxes. Now we can see it's not by much, but Class B have a slightly higher median. We need to say what that means. It means that they scored slightly higher on their quiz out of 20. Okay, so if I'm giving this as like an answer for a test, I would say that Class B has a higher median, meaning they scored higher, on average. Okay, you'd need to say what it is, which one is bigger, and what that means. And it means that in this case, they scored slightly higher on average. Now, the interquartile range, the difference between our lower quartile and our upper quartile. For Class A, we can see that it's slightly smaller. That box there is smaller. Okay. What the actual value is, it's quite difficult to say, but we can definitely see that the box is smaller. And remember, we said that if we had a smaller box, that meant things were more consistent. So, we can see that Class B had a higher median, meaning they scored higher on average, but Class A has a smaller IQR, meaning, and again there's that word meaning, we have to give that interpretation, they had more consistent scores. And I would always drop that word consistent in, okay? Because that is what the interquartile range is showing us. It's showing us the consistency of the data that we've been given. Okay? So once again, it's time to hold over to you. I'm going to give you two box plots, very similar kind of scenario. You'll see that the box plots are different. I'm giving it over to you to tell me, what are these box plots showing me? Okay, what are they showing you? How are you going to interpret them? Okay, here they are. I'll give you a chance to pause. Okay, so hopefully you've had a chance to pause. If you've not, your last chance is right now, because otherwise I'm going to be going through it. And you need to be doing these, because this is the practice that you're going to get. Right, let's see what we've got. Now, we have that the median for Class A, that line in the middle of our boxes, is quite a bit higher for Class A. So we can say Class A has a higher median. And again, we have to say what that means. So meaning they scored better on average. Okay, and you might have to interpret what the box plot's about. It could be to do with the length of time that something takes, in which case, or it could be like a race time, in which case having a lower median would be better because you would want to complete the race faster, right? So there's one thing. Class A has a higher median, meaning they scored better on average. Looking at their interquartile range, it's also more consistent. So Class A is also has a smaller IQR, meaning they were more consistent. And again, I've dropped that word consistent. Now, we could make a solid recommendation here. We could say that overall, Class A has scored better, and they have been more consistent, so they did better in that test. However, there's one thing that we can tell from these box plots to do with Class A, and that's to do with their extreme values. They've got an extreme low and an extreme high. So although the middle 50% are doing, like, I would say, better overall than the middle 50% of Class B, Class B overall is much more tightly knit, where Class A has maybe got an extreme high and extreme low. Okay, but in terms of our comparisons, we only really need to compare the medians and the interquartile range. Okay, so there's your box plots. There is your there are your quartiles as well. Now, I said that I was going to do a final bit for this video, and I make this the final bit, otherwise I think this video will get perhaps a little bit too long. And I'm going to show you some stuff to do with the calculator, so I'm just going to set that up now. Okay, so I've got myself set up so you can see my calculator. Now, with at least the new calculators, that's not just the white one, but the new version of the standard one, the black one. You can do some statistics straight away on that calculator, which make them very useful. You can also do some table statistics on them, which makes them incredibly useful. However, not all calculators will be able to do this. Some will be able to do it to a very basic degree. They might only be able to work out like a mean, but some of them will be able to do some very advanced things. Okay, so let's take a look at what we can do with this calculator. The first thing is to get it in the right mode with these new calculators. So we're looking for a mode that is called statistics. Okay, so I'm going to hit 6 for statistics. Now, It gives you a load of different options. I don't care about any of these except for the top one. So I'm going to press 1 for one variable, meaning it's just numbers. Okay. And it's giving me a table which is asking me for my values and my frequency of that value. Okay. Now, if I don't want to spend ages programming my calculator, I can just type in my numbers. So I can type in 27, 26, 15, 23, 29, 30. Now, I could put 30 and a frequency of 2 if I wanted to, or I can just keep typing. I'm going to just keep typing. 8, 14, 32. There's my second 30, 27, 26. And you can see that it said I've got 12 numbers because I've put each number as a separate entry. And you might think, okay, well, that's all very good. What do I do now? You have got this thing called option here, which will display your options. Now it's giving you, we can edit our data if we press 2. I can do a one variable calculation if I press 3. Now that's what I want. I press 3, it's going to spew out loads of different things, which, a lot of them we don't need, but some of them we do. I'm going to show you which ones we do need. The top one here, where it's got X with a little bar on the top, that is the posh notation for the mean. So that top number there is your mean. Okay, it's got a load of stuff down here that at GCSE we don't need. And then here it starts to give us some more useful information. It tells us that we have 12 pieces of data. That's our n. Our minimum value was 8. Our first quartile, so our lower quartile, was 19. Our median was 26.5. Our upper quartile is 29.5. If I tick over to the last one, it tells me my maximum value is 32, which is pretty cool, especially for those lower quartiles, because then I can do, 29.5, take away 19 to give me my interquartile range. And you're thinking, well, sir, this is all very well, but, I can do those ones without any calculator help. The ones that I really would like to be able to use my calculator for are the table questions, because it's the table ones that were more difficult. All right, then. Take a look at that. I accept your challenge. So, I need to clear my data first of all. So I need to... Oh, no. So let's say I'm back here. I need to go Option 3 to look at my data. And I want to completely override this. This data can... can do one. So here we go. Let's do this. So 0 for my first value. Oh, whoops, I'm pressing the wrong button. Come on. You're on camera and you're messing it up. Right, I'm going to go to the right to override my frequency and give that a frequency of 7. Okay. My X value is 1. In fact, let's do my X values first. 2, 3, 4, 5, 6. I don't need... how am I going to delete those? I would have thought just hitting that. Ah, there we go. Yeah, hitting delete deletes your other numbers. There we go. Can you tell that I'm figuring this out as we do it? Right, so 0 we want to keep. I want to do my frequencies now. So we already put in 7. I got 10, 14, 20, 22, 19, and 7. There we go. We've put in all of our data there. Just to double check. 0, 7, 110, 214, 320, 422, 519, and 6 and 7. If you can remember what to do next, we're going to hit Option to view our different options. And I want to do a one variable calculation to get all my different numbers. And here we go. We've got our top one, which is our mean, which is 3.2626262626. If I go on to my next page, I then got 99 pieces of data. My lowest is a 2. My lower quartile is a 2. My median is a 3. And my higher quartile is a 5. Oops. Let's just double check that against what we had before. We had the lower quartile was a 2. Our median was a 3. And my upper quartile was a 5. We've got exactly the same answers. So if you've got one of these and you're thinking about doing some quartiles, if you're confident with programming things into your calculator, this can be an absolute bonus, in my view. Okay. But if you don't have one of these calculators, and I don't expect you to have one of these calculators, you know, these calculators are not cheap. You know, £22 to £25 a calculator, they are not cheap. You can still work things out the more traditional method through what we've done in this video. Okay. Quite a long one today, even with the little tutorial bit right at the very end, it became quite a long one. So I'm going to stop things there. If you want the additional practice, you know, as always, the worksheet is attached. The answers are attached as well as well as this PowerPoint. And yeah, use this as your revision. Use this to help you. Okay, I'm going to stop things there, and I'll see you next week.